Can somebody confirm that I am audible? Please, somebody unmute yourself and confirm that I am audible.
Yes, sir, audible.
Okay, is my screen visible?
Yes, sir.
Okay, okay. So let us start with. So basically, in the previous lecture, we have discussed CI engine combustion, um, and we are going to continue. But before moving ahead, there were some students saying that due to network problem, they were unable to hear me completely in the previous lecture. So let us revise what we have discussed earlier, and then we will proceed. So, the combustion in CI engine is our chapter number 6. Basically, this is what the combustion is, which we have already learned. It is a hydrocarbon fuel. With the help of oxidant, it is being oxidized, and result is carbon dioxide and water are the products, and liberating some amount of heat which we require for conversion into work. So it is being represented as CH4 plus 2O2 gives CO2 plus 2H2O plus heat. There are some requirements for the combustion to happen in CI engines. Um, Being CI engine, presence of hot air in the combustion chamber is the first requirement. And in order to achieve this particular first requirement of hot air, we have to use sufficiently higher compression ratio of more than 16:1. So here we mean to say we require hot air in the combustion chamber. Now, why we require hot air? Because we are not providing separate ignition system in CI engines. We are not providing separate ignition system in CI engines. Since we are not providing separate ignition system, what we have to do is we have to ensure that in order to ensure that the fuel whichever is going into the combustion chamber is going to burn, we have to ensure that the air inside the combustion chamber is hot enough. To what extent? To the extent that whenever we spray the fuel into the combustion chamber, it is going to burn automatically, self ignition. And to what extent it has to be hot? Since it is supposed to be burn on its own, auto ignition has to happen. The air temperature has to be above auto ignition temperature of the fuel. So that is the requirement, and that is where we have to increase the temperature of the air to a very high level. And for this, we require very high compression ratios above 16:1. So that is the reason why we generally use higher compression ratios in CI engines. Some means for introduction of fuel as per requirement. And this forms a heterogeneous picture. So, since we are going to introduce fuel into the combustion chamber, we require some system wherein we are going to introduce the fuel into the combustion chamber. And when we say we are going to introduce into the combustion chamber, we are not going to pour it into the combustion chamber. So in a systematic manner, we have to ensure that it is going to be introduced. And what a systematic manner it is required? We want it in the form of atomized fuel, small droplets of the fuel. And When we say small droplets, we require a system which ensures that the fuel is being broken up into small droplets, and that is where you have the fuel injection system. So we have discussed fuel injection system for CI engine in chapter number 4 in detail. So chapter number 3 in detail, wherein we have understood that how the fuel injection system for CI engine works with a fuel injection pump and injector, etc. So we have discussed in the detail, and we have also discussed that we will be having a heterogeneous mixture. We will be having a heterogeneous mixture. And what do you mean by saying heterogeneous? When we say it is heterogeneous, we say that the sample, if you take different samples from the different corners of the combustion chamber, the amount of fuel which is going to be amount of fuel and amount of air going to be in this particular samples will not be same for all the samples. And why it is so? Because the mixture is heterogeneous. Controlling parameters for sustained combustion. So in order to ensure sustained combustion, we have to ensure that the type of reactor and the type of combustion chamber has to be as per the requirement chosen, so that a sustained combustion is ensured. Obviously, the last requirement is we have to ensure that air and fuel present in the combustion chamber is going to be utilized optimally to its optimum level. And in order to ensure this, the injection duration, the rate of injection, and the air motion has to be controlled properly. So the injection duration means the duration in which we are going to inject the fuel. So from the start of the injection to end of the injection, what is the timing? So that is the injection duration. So this injection duration is what we are going to control whenever we say we want to higher more power or less power. If we want higher power, we are going to increase the duration, and when we are going to we want lesser power, we are going to decrease the duration of the injection. The rate of injection. So per unit time, what is the amount of fuel coming out of the combustion chamber is what we call as the rate of injection. So what is the rate of injection we want to have? Then the air motion. So whenever the air is going to move inside the combustion chamber, the mixture is going to form properly, because we are unlike CI engines, the mixture formation is happening in CI engines inside the combustion chamber, and therefore the air motion is required. So proper air motion is imparted into the air so that proper air mixture is being formed. So this is how these are the different requirements of a combustion combustion in case of CI engine combustions. A normal combustion happens in CI engine. Let us see how it happens. Here we all know that we have a heterogeneous mixture, because we are spraying the fuel into the combustion chamber, and while spraying we are unable to ensure that all the fuel is being equally distributed throughout the combustion chamber. Is not able to be ensured, because we have a mechanical system where we are going to spray the fuel, and when the spray is happening, the spray pattern is not similar to that of a combustion chamber shape, and therefore the fuel in different parts will be reaching in a different quantity, and therefore the mixture is going to be heterogeneous. And this is how P theta diagram, that is pressure crank angle diagram for a CI engine looks like. Already we have discussed P theta diagram for SI engines. So when we talk of normal combustion, basically for the combustion to start, we have the basic difference starting from the induction, that is suction stage. In during the suction stroke in CI engines, we are only sucking the air. So air is being introduced into the combustion chamber initially, unlike in SI engines, we are introducing the air fuel mixture, air fuel vapor mixture we are seeing. Okay, so here only air is being introduced, and then the charge is compressed with the help of the piston in the cylinder. So the piston moves from BDC to TDC, and as the piston is moving towards the TDC from BDC, the volume is being decreased, and therefore it is getting compressed, and therefore the temperature increases. And at the end of the compression stroke, that is as the piston reaches near to the top dead center, we are going to inject the fuel. And here the fuel droplets are going to burn independently, which means to say that every droplet is burning independently. Unlike in SI engines, we have a uniform mixture throughout the combustion chamber. The continuity was very important. And since there was a continuity in the mixture, once we ignite the mixture at one corner or any corner of the combustion chamber, the whole mixture is going to be burned because the flame is going to travel in case of SI engines. Unlike in here the flame cannot travel because there is no continuity, because now the air fuel mixture is not continuous, it is not homogeneous, it is heterogeneous. So due to the heterogeneity, that is discontinuity in the availability of the fuel, the flame will not be able to travel throughout the combustion chamber. And therefore, if one droplet burns, not necessary that the next droplet is also going to burn. One fuel droplet is going to burn, not necessary that the next droplet is also going to burn. So that is the reason why we have initially itself, we have ensured that the temperature of the air itself is higher to the extent that the temperature of the air is going to be higher than the self-ignition temperature of the fuel. And when the fuel is being droplet, every fuel droplet is now surrounded by air, which is having a temperature higher than the self-ignition temperature. So here we have something like this. So here we have something like this. Suppose this is your droplet. This is your droplet. Then the air here, and this is the fuel. This is your fuel. So this particular droplet is going to burn independently. Why? This is getting heat from air outside. So heat is being introduced and the fuel is going to flow outside. And at this particular boundary layer, a layer of air fuel mixture is going to form. A layer of air fuel mixture is going to form. And this air fuel mixture will start burning at this particular somewhere when the mixture at some region becomes within the inflammability limit, and when it has the temperature above self-ignition temperature, it starts burning, and then the flame starts burning from outside to inside, So every droplet is burning independently. Now the flame here is traveling from the periphery of the droplet to the center of the droplet. So every droplet is going to burn like this, with a droplet starting its burning from the surface, and the flame is traveling from the surface to the center of the droplet. Every droplet is burning independently. So when every droplet is burning independently, we have that particular amount of fuel burning but not necessarily the next fuel is going to burn. So next fuel droplet is going to burn, and it is also, as we know, there's no ignition system used, because obviously here the ignition system was not able to be used, because one droplet is here, another droplet is here, another droplet is here. So if you are going to give ignition system, suppose a spark is given for this, what about this? Here again, are we going to use a spark plug? Are we going to give a spark plug to this also? No, not possible. So for every droplet, giving one separate spark plug is also not option. And therefore, we cannot use a spark plug system in case of CI engines. We have to use CI ignition type of ignition, that is compression ignition system, wherein we are increasing the air temperature to such a level that all the air inside the combustion chamber is hot enough, and when we spray the fuel in the form of a droplet, so this particular droplet will get the heat from outside, will get the heat from the air over here. So this is air, this is fuel. So this fuel droplet will get the heat from the air outside. So, and here uh, oxygen is going to move inside, and fuel is going to move outside. Fuel is going to move outside, hydrocarbon. So this oxygen or air moving inside and hydrocarbon moving outside will result in the formation of a mixture over here. So this is a mixture layer. So now we have a droplet which is, so this is now the mixture. So this is your mixture now. So we have a droplet here in the liquid form at the center. We have here a layer of air fuel mixture around this particular liquid droplet, and this particular mixture formed around the liquid fuel, whenever it reaches the self ignition temperature, and if it is in the inflammability limit, then it will burn. Once the burning starts at any corner, that flame will be traveling, and it will be reaching all the surface, burning all the initially all the surface mixture whatever has been formed, and that flame has to travel towards the center of the droplet. So that is where we are saying every fuel droplet is burning independently. Every droplet is burning independently, wherein last time when we discussed, we said that the scenario is something like this: when on a Diwali day, when we are looking into the sky in the morning, early morning, we can see that crackers are being burst. Here and there we can see some lightning due to crackers, burning of the crackers in the sky. Okay, in a similar manner, some droplet whichever has been reached to the point where it can burn, it will burn. Then some another region, some another droplet will burn. So there is no continuity in the burning. So what we need to understand is here is not necessary that if this particular droplet burns, this droplet will also burn. Not necessary. Okay. So it may happen that this burn, and then the other corner here some droplet will burn, then here some droplet will burn. So there is no continuity. Every droplet is burning independently. Whenever it reaches self ignition temperature, that will burn. So not necessarily its neighbor droplet is being burnt or not burnt. Irrelevant. It is irrelevant. Okay. So of CI engine and SI engines. In SI engine, we had a air fuel mixture which was homogeneous. Homogeneous. So we had a homogeneous mixture throughout the combustion chamber, and we were burning the mixture at one corner, and homogeneous mixture. In SI engine, it was a homogeneous mixture, and therefore it was possible to burn the fuel in a continuous manner, where we had a flame at spark plug, starting the flame from the spark plug, and the flame was traveling to all corners of the combustion chamber. Here, unlikely here, we don't have that. We don't have that. Here we we are not getting the mixture to be homogeneous. Here we have a heterogeneous mixture, and every fuel is in the form of a droplet, and therefore every droplet is going to burn independently. So that is very important. Ensure proper air motion to complete the combustion. So in order to ensure the complete proper mixing of the air and fuel, as well as ensure the complete combustion, we require air motion. So this was not the one of the requirement in case of SI engine. So this is one of the requirement in case of CI engine, where we are talking of proper air motion. Air motion is required. Proper air motion as per the design of the combustion chamber. We require specific type of air motion to be imparted to the air inside the combustion chamber. So whenever the air is going to move, then and then only we are going to ensure that the fuel and air mixture is formed properly, and that mixture is going to burn properly. So in order to ensure complete combustion, it is very essential that we should ensure proper air motion in the CI engine combustion. And the injection duration is controlled to ensure power requirement. Means, as per the requirement of the power, the injection duration is going to be controlled. What we mean to say is, when we want more power, the duration will be more, injection duration will be kept more. When we want less power, the injection duration will be kept less. म्हणजे आपल्याला जास्त पॉवर पाहिजे असेल तर we will be injecting the fuel for more amount of time. आता नळातून पाणी येते, आपण जास्त वेळ जर बादली नळाखाली ठेवली तर जास्त पाणी येईल, कमी वेळ नळाखाली पाणी ठेवलं तर कमी पाणी येईल. So in the same manner here, as the injection duration is more, the more fuel will be injected, and more fuel is going to burn, and more power will be produced. If the injection duration is kept less fuel is going to be injected, less fuel is going to be burned, and less power will be produced. What we did in case of SI engine, we control the quantity of mixture being supplied into the combustion chamber. And we said we are going for quantity governing. Here what we are saying? Here we are saying quality governing. Quality governing. Why? Because when we inject more fuel, the mixture quality is becoming rich. When we are injecting less fuel, the mixture quality is becoming lean. Comparatively. Okay, comparatively we are talking rich and lean. Comparatively we are saying. बरोबर का? Air तेवढीच आहे, लेस फ्युएल टाकलं तर मिक्सचर लीन होईल कंपॅरेटिव्हली, आणि एअर तेवढीच आहे, आपण जर जास्त फ्युएल टाकलं तर कंपॅरेटिव्हली मिक्सचर विल बिकम रिच. सो वी आर चेंजिंग द क्वालिटी हियर. We are not changing the air quantity. Okay, we are not changing the mixture quantity. What we are changing is the mixture quality. Okay, and therefore the CI engines are said to be quality governed engines. Where in SI engine we said it was a quantity governed engine. Here we are saying that this is a quality governed engines. So why we are saying quality governed engines? Because this statement. So this is the reason why we call it as a quality governing. So why? Injection duration is controlled to ensure power requirement. So as we change the injection duration, the amount of fuel injected into the combustion chamber is going to change. And as the fuel injected into the combustion is going to change, the quality of the mixture is going to change. That is, if you inject more fuel, the mixture will become rich. If you inject less fuel, the mixture will become lean. And that is where the quality is changing. That is where the quality is changing. So if the quality of the mixture is less or higher, that is lean or rich, that is what we are doing for increasing or decreasing the power requirement as per requirement. That is, as per requirement, if you want to increase or decrease the power produced by the engine, then what we are doing, we are going to change the duration of injection. We are going to change the duration of injection. If the injection duration is more fuel will be injected. If the injection duration is less fuel will be injected. If less fuel is injected, the mixture will be comparatively lean. If more fuel is going to be injected, the mixture is going to be comparatively rich. So when we are changing the quality of the mixture to change the cope up with the change in power requirement, म्हणजे जसं power requirement change होईल तसं आपल्याला mixture ची quality आपण change करतोय. And that is where we call this CI engines as quality governed engines. Quality governed engines. In SI engine, we said it was a quantity governed engines, and here we are saying CI engines are quality governed engines. Combustion completed in 4 different stages. In SI engine, it was 3 different stages. Here we have 4 different stages. This is how a normal combustion takes place in CI engine. So I hope everybody understood how the normal combustion is happening in case of SI engine. Any doubt? Anybody having any doubt in whatever is being discussed till now? Can anybody confirm with me? Can anybody confirm with me? Yes. Can anybody confirm?
Yes.
Yes. Okay. So expecting that everybody has understood everything, whatever has been discussed. So we will proceed then. So म्हणजे काय, आतमध्ये एअर आहे, ते एअर मध्ये फ्युएल आपण इंजेक्ट केले, ते फ्युएल जाणार, फ्युएलला ज्या वेळेला फ्युएलच्या सरफेसला पहिल्यांदा मिक्सचर तयार होणार, कारण मिक्सचर फ्युएलच्या सरफेसला ड्रॉपलेटच्या सरफेस मध्ये काय झालं, ड्रॉपलेटच्या आतमधून फ्युएल बाहेर येते, ड्रॉपलेटच्या बाहेरून एअर आतमध्ये जाते आणि सरफेसला एक एअर फ्युएल मिक्सचरचा लेयर तयार होतोय. आणि एकदा का ती लेयर तयार झाला की ती लेयर ज्या वेळेला सेल्फ इग्निशन टेम्परेचरला पोहोचेल, इन्फ्लेमेबिलिटी लिमिट मध्ये असेल मिक्सचर, तर ती बर्न व्हायला चालू होणार. आणि एकदा बर्न व्हायला चालू झालं की flame will travel from outer surface of the droplet to center of the droplet. So this is how the combustion is happening in case of CI engine. And therefore every droplet is going to burn independently, and to ensure proper air mixture formation and burning, air motion is required. And to control the power requirement, we have to change the injection duration, and all these things happen in 4 different stages. And if this happens in this particular manner, planned manner, then we call it as a normal combustion in case of SI engines. Okay. Now let us talk of different stages. So the different stages, we have 4 different stages, as we said. Now the 4 different stages are, first stage is from A to B. A to B, we call it as ignition delay. In SI engine, we call it as ignition lag. Here we are calling it as ignition delay period. A to B. We have the second stage, which we call as rapid combustion stage or uncontrolled combustion stage. From B to C, we have a third stage, which we call as controlled combustion stage, that is C to D, and we have a fourth stage after D. So after point D, we have the fourth stage, which we call as afterburning stage. So A to B, we have ignition delay period. B to C, we have a rapid combustion stage or uncontrolled combustion stage. And the third, we have C2D, we have controlled combustion stage, and fourth, we have afterburning stage. Okay, so these are the 4 stages in which the combustion in CI engine happens. So here, this will question in the exam will be something like this. Explain with a P theta diagram the combustion process in CI engines. Then you have to draw this particular figure, mark all these particular points, and you have to explain this particular list, all these particular 4 stages first, and then one by one you have to explain every stage in detail, what is happening in every stage. Okay, so these are the stages of combustion in case of CI engines. So let us now see what happens in different stages. So the first stage, so as we have just said, we are calling this particular stage as ignition delay. Unlike in SI engine, we call the first stage as ignition lag. So it is from A to B. What is the A point? The point A is the start of injection point. Okay, and what is the point B? If you see the figure, it is clear that the point B is the point where the combustion curve departs from your motoring curve. So in SI engine, the first stage was the spark point to the point where the combustion curve departed from motoring curve. Here we have the first stage. A point is point of injection, start of injection. So here at point A, we are starting. See here, this is a top dead center. This is a top dead center. So nearer to top dead center, we say we are starting the injection. We are going to inject the fuel. So here we are starting the injection. So at point A, we have started the injection. Okay. And point B is when the combustion curve departs from your motoring curve. So when the combustion curve departs from motoring curve, at that particular point, we have the end of our stage number 1. Okay, and this particular stage is called as ignition delay period. Ignition delay period. We say combustion starts. Actually, combustion starts. Okay, actual combustion starts. Okay, it is not actual because here point A where the fuel was injected. Okay, so here the fuel was injected, and here we say the combustion starts. And why we say it starts? Because when the combustion starts, the result of combustion is seen in the combustion chamber in terms of increase in pressure and temperature. And here very clearly we are able to see the increase in pressure, correct? So increase in pressure is due to increase in temperature. So here, since the pressure is increasing, that is why the curve is departing from your motoring curve. So the point at which the curve departs from motoring curve is your point B. So that is your end point for stage number 1. So where we say the point of combustion. So the first stage is from the point of injection, starting of injection, to point of starting of combustion. And basically, this particular stage from A to B is being divided into 2 parts. Okay, and the first part is called as a physical delay period, and second part is called as a chemical delay period. Okay, ignition delay period is subdivided into 2 periods or 2 parts. One is this physical delay period where formed. So mixing period or formation of mixture is happening in a particular amount of, because you are just see, you have introduced a droplet, but the droplet you have just introduced a droplet. You have introduced a droplet into the combustion chamber, but this is in the liquid form now. Isn't it? This is in the liquid form. So if this is in the liquid form, can it burn? Obviously no, isn't it? So this liquid fuel cannot burn, and before burning, it has to form a mixture. And in order to form a mixture, then there will be the fuel has to diffuse out, and air has to diffuse in. Then and then only you are going to get mixture, isn't it? So here we have a droplet, and this particular droplet is going to burn, droplet which is going to combustion inside, going into the combustion chamber, and this is in the liquid form now, liquid fuel. And this particular layer, outside layer, is initially going to form a mixture. So here the mixture is going to form. Why? Air is going to come in, fuel is going to come out. So they are trying to diffuse in each other. Air is trying to diffuse in fuel, fuel is trying to diffuse in air, and therefore a layer of air fuel mixture is formed on the surface of the droplet. So this will be all the surface. So here, so this here you will be having a mixture. So there will be a mixture forming around this particular droplet. So this is where the mixture is being formed now. Okay, so this particular mixture, so this is your mixture now, air fuel mixture. Okay, so this particular mixture, air fuel mixture, has to reach self-ignition temperature, has to reach inflammability limit, and then it will burn. So first the mixture formation has to be there. So mixture formation has to be there. So during this period, obviously there will not be any burning. Okay, so the first stage is the physical delay period, where physical things are happening. What physical things are happening? Air is moving, trying to diffuse in, fuel is trying to diffuse out, and the mixture formation is going to be there. So all these particular physical things are happening, and therefore the first sub stage of the ignition delay period is called as physical delay. Okay, physical delay. And second subpart is called as chemical delay period. It is interaction period. So the fuel is now going to interact with the air. So mixture is going to form. It is trying to burn. So now the mixture is getting heat, okay, and it is trying to burn. So somewhere here and there, some molecule will reach self-ignition temperature, and it will try to burn the mixture. Okay, so if one molecule over here starts burning, will it able to burn completely? No, this particular flame has to travel, and then all the mixture has to burn, correct? Then and then only we can say the complete droplet is going to burn. So initially one molecule over here, one hydrocarbon molecule over here, or suppose one molecule over here starts burning, can we say all the fuel has burned? No. So this flame has to catch all the mixture. Okay, and this particular chemical activity is happening, chemical interaction is happening, or in case the ignition is going to start, ignition of the mixture is going to start, and therefore we call this as a chemical delay period. So your ignition delay period is now divided into two parts. One is the physical delay period, and second is the chemical delay period. In physical delay period, fuel in the fuel droplet which is there in the air, now the fuel is trying to diffuse out, air is trying to diffuse in, and a layer of mixture is formed around the droplet, and the mixture is being formed, because we know that in order to burn the mixture, first the mixture has to reach inflammability limit and self-ignition temperature. So there will be some amount of requirement of time, and this is the time where our droplet is there inside the combustion chamber, but it is not able to burn. Okay, because it has not still now converted into mixture, it is only in the liquid form. So once it is going inside, first the fuel will try to diffuse out, air will try to diffuse in, and a layer of so we have here one droplet. We have here one droplet we have here one droplet. So this is our droplet where a layer of mixture is going to be there on its periphery. So this is now mixture. This is the mixture now. And this is a liquid fuel. And this is the liquid fuel. Liquid fuel. Liquid fuel. Okay. So here now we have a liquid hydrocarbon fuel, and here is the air fuel mixture. Air fuel mixture. So this particular air fuel mixture, somewhere one molecule over here starts burning, but all this mixture has to catch fire. Mixture burning, then and then only it can result in production of heat. So that particular period when this particular flame is going to form inside this mixture formed around the droplet is what you call as a chemical delay period. So we have two periods. One is a physical delay period and one is a chemical delay period. During physical delay, the mixture is being formed. Mixture is being formed. Okay. Mixture formation is going to happen. Okay. How the mixture formation happens? We have a droplet inside the combustion chamber. Fuel is going to diffuse, trying to diffuse out. Air is going to try to diffuse in. And therefore, at the boundary of the droplet, at the boundary of this particular boundary of the droplet, you are having a layer of mixture. So in inner layer is liquid, outer layer is air fuel mixture now. Okay. And once this mixture is formed, then it starts taking heat. It starts taking heat. So taking the heat, absorbing the heat, and reaching self-ignition temperature where the mixture can burn completely, it will also require some amount of time. And all these things are happening in the chemical delay period. So some chemical things are happening, some interaction is happening, chemical molecular activity is happening. Okay. And therefore we call this as a chemical delay period. So one physical delay period is there, one chemical delay period is there. So the ignition delay period is divided into two parts. So this is a complete ignition delay period, A to B. Here it is A, here it is B. A, B. And this A, B is being divided into two parts. One D is a mixing period, which we call as a physical delay. E is called as a chemical delay period. It is an interaction period. And during mixing period, the mixture is being formed. And during chemical delay period, ignition is going to start. Okay, ignition is going to start. So that is how we have the two sub stages of your first stage of combustion, which we call as ignition delay period. Basically, what happens in this stage? During the fuel physical delay period, so it is very clearly mentioned, fuel is being atomized. So whatever fuel is going inside is going to atomize. It has to atomize, isn't it? Droplets, the flow coming out of the fuel flow coming out of the nozzle is going to break, and atomization is going to happen. Then vapor is going to vaporize. Air is going to mix in, fuel is going to mix out and diffuse out and diffuse in, and a mixture is going to form. So before that, the fuel has to vaporize. So atomize, then vaporize, then mixture is going to form. So the mixture has to form with air, fuel is going to mix with air, and then it reaches self-ignition temperature. So all those things happens in physical delay period. All these things happen in self-ignition temperature. Sorry, physical delay period. So what all things happen is a physical delay period. Fuel is atomized, vaporized, mixed with air, and reaches self-ignition temperature. So very clearly, fuel is atomized, vaporized, is mixed with air. Correct? So see, this is completely droplet, complete big droplet. पाणी थेंब थेंब नळातून पडतंय ती ड्रॉपलेट. ती जर खाली पडली, जमिनीवर पडली तर ती बघा ठिकरे उडते. सो ॲटमायझेशन, स्मॉल ड्रॉपलेट्स, स्मॉल पार्टिकल्स. ओके. सो हिअर काय इथं काय होणार, एक फ्युएलचे मॉलिक्यूल, इथं कुठेतरी एक एअरचे मॉलिक्यूल, इथं कुठेतरी एक फ्युएलचे मॉलिक्यूल, इथं एअरचे मॉलिक्यूल. सो इट इज ॲटमाइज्ड. So once this is atomized and diffusing into the air, and air is going to diffuse in, then and only their mixture is going to form. So we have first atomization, then vaporization. That will pick up the heat, it will convert into vapor, because vapor is going to burn. Liquid fuel is not burning, so vapor is going to burn, so it has to be vaporized, mixed with air. The mixture has to be formed properly within the inflammability limit, and then the mixture reaches self-ignition temperature. So all these things are going to happen in the physical delay period. During chemical delay period, what is going to happen? Chemical reaction starts. Some molecule somewhere starts burning, and all the complete droplet starts then burning. So the point from where some molecule somewhere starting burning and the complete droplet starts burning. So the fire is being touched throughout the periphery of the droplet. So from the point where one molecule somewhere starts burning to the whole droplet catching fire is what is going to happen in case of chemical delay period. Okay, still it has not produced sufficient heat so that heat can be imparted to the combustion chamber mixture. Okay, it has only start burning. Okay, so आपण ज्यावेळेला फटाके उडवतो बघा, फटाके उडून टाकले ते पहिल्यांदा थोडस वेळ लागतो त्याला सुर 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 आणि नंतर फट दिशेने पडतो. सो दॅट पिरियड इज इग्निशन डिले पिरियड. ओके, सो इट इज प्रिपेअरिंग इटसेल्फ फॉर बर्निंग. Okay, so first in the physical delay period, what all things happen? Atomization, vaporization, mixture formation, and it reaches self-ignition temperature. So all these things happen in the period D, this particular period D, which we call as a physical delay period. Physical delay period. And then the chemical reaction starts, and whole droplet starts burning. It has not completely burned, but it just starts burning. Okay, from the some molecule starting burning to whole droplet starts burning. It is what? So the chemical reaction starts and whole droplet starts burning. So this is your chemical delay period. So your ignition delay period is subdivided into two parts. One is the physical delay period and second one is the chemical delay period. In the physical delay period, the fuel is going inside, is in the form of a flow. Okay, that has to be atomized first, then it has to be vaporized, it has to be mixed with air to form a mixture, then it has to absorb the heat and reach at a self-ignition temperature. So all these things happen in the physical delay period. And what happens in the chemical delay period? Some molecule somewhere in the external periphery of the droplet starts burning, and from that point the whole droplet starts burning. So between this particular, some chemical reactions are happening, isn't it? So the mixture is starting burning, so chemical reactions are happening. So some in the first period only physical things are happening. In the second period we have some chemical things happening, and that is where we call it as a physical delay period, and second stage substage as a chemical delay period. Okay, so in all, that is our first stage. So the first stage of combustion is what you call as the ignition delay period, and in the ignition delay period we have two substages. One is the physical delay and second is the chemical delay period. So this is what happens in the ignition delay period in CI engines. So can I get confirmation from a student end that they have understood what is happening in the first stage of combustion, which we call as the ignition delay period? Can I get confirmation?
Yes, sir.
Can I get confirmation?
Yes, sir. Understood.
You have doubt or you understood? You understood? Hello? Yes, somebody. Once again. Yes. Yes, understood everybody. Anybody having any doubt, please ask. Once again, I will explain. This is the first stage, starting from A to B. Point A is the starting of the injection till point of B, where the we can say in one words, we can say it is starting of combustion, or in other words, we can say the combustion curve departs from motoring curve. So that is your point B. And between this A to B is your ignition delay period. In SI engines, we call it as ignition lag period. Here we are calling it as ignition delay period. And this particular ignition delay period, complete delay period, has been divided into two parts. Okay. So in this particular ignition delay period, two things are happening. Preferably some physical things are happening, and then some chemical things are also happening. So on that basis, we have divided this ignition delay period into two parts. One is the physical delay period, and second one is the chemical delay period. And what all things happen in the physical delay period? Fuel is being atomized, it is being vaporized, it is being mixed with air, and then it reaches self-ignition temperature. So all these things happen during the first stage of first substage of the ignition delay period, which we call as physical delay period. And in the second stage of the ignition delay period, we call it as a chemical delay period. The chemical reactions are starting, and the droplet is going to start its burning. Okay, so that is where we call this as a ignition delay period. So very clearly, the ignition अजून start झालं नाही. Ignition अजून सॉरी बर्निंग अजून कंबशन अजून स्टार्ट झालं नाही. ड्रॉपलेट आतमध्ये सोडलं, तिथूपासून ते कंबशन स्टार्ट झालं, त्यापर्यंतच्या पॉइंटला आपण इग्निशन डिले पिरियड असं म्हणतो. सो व्हॉट एव्हर डिले इज हॅपनिंग बिटवीन द पॉइंट वेअर वी आर इंजेक्टिंग द फ्युअल टू वेअर द कंबशन, वी कॅन से द कंबशन हॅज स्टार्टेड. या दोन पॉइंटच्या मधल्या वेळेला आपण इग्निशन डिले पिरियड असं म्हणतोय. आणि त्यात दोन भाग आहेत, फिजिकल डिले आणि केमिकल डिले. Some physical things are happening in physical delay period, some chemical things are happening in chemical delay period. तर ह्या सगळं तुम्हाला गोष्टी ज्या वेळेला फर्स्ट स्टेज बद्दल विचारेल त्यावेळेला तुम्हाला लिहायच्या आहेत. ओके, so since no doubts are being asked, I assume that you are understood. Mark your attendance. Mark your attendance in the chat box and may email you, because you have some lecture.